So I've got a picture of a piston up on the screen, and you can see the animation of the piston and the movements that it actually has. So we want to actually draw this piston in FreeCAD and use the same animation you see here to actually drive the kinematics on screen in FreeCAD. So this is actually quite easy to do using a technique called a master sketch. Now, a master sketch is basically a skeleton of movement that we're going to use, and the constraints will allow us to actually create mechanical movement and later control it with a Python script, and that will actually allow us to hang off our parts on and our bodies onto the actual skeleton to allow this type of movement. So it's quite easy to do. So what we've got to do is analyze the motion of this movement, and the first thing we do is look at our fixed point. So we know our fixed point is here. Let's bring this up on screen a bit, and that's what we want, this one here. So let's zoom in a bit. So we know our fixed point is here. So first going to FreeCAD, create a new sketch, and we want to jump into the sketch at workbench, which we have here, and start a new sketch and attach it to the XY plane. So we're now in FreeCAD, and we want to look at anchoring our fixed point in the center at this point here. So what I'm going to do is bring up a few panels on the right hand side to help me out. So I'm going to look at the selection view. So I've selected our root point here, as you can see here. So what I'm going to do is create our first line, which is going to be this. Trying to show you what it is with a rotating object is quite hard actually. So I want to create this first line here. So going back to the sketch, and I'm not going to use construction geometry for this. There is a reason why, and I'm just going to create our first line. So the sketch sits at our master node here. So this is the first thing you do is create the sketch. So I'm going to create a line there, and I can constrain this point, and this is going to have 1 degree of motion around here. Sorry, 2 degrees of motion, not 1 degree. 2 degrees of motion, or 2 degrees of freedom. So rotation around here, and so I want to constrain the length of this, and I'm going to go to 30. Now it's got 1 degree. That's it. Now it's got 1 degree of freedom, because if we constrain the length, we can't actually stretch this in and out here. So this is what we want: 1 degree of motion. I was right the first time. So that's good. So the next thing we want to do is to do the rod here. So we add this in. So we're just building a skeleton here of the actual movement. So we can use lines again. That's all we need, just simple line tools. At the moment we can see this one's got 5 degrees of freedom, which is way too much. So if we can strain this down to these 2 points, because they will be connected, and we'll constrain the length, and I'm going to go 60 on that one. So this got 2 degrees now, so I can basically go up and down and left and right. Now, the thing is this has got to actually stay in the center of this line here, because if you look at the piston moving up and down, this is all centralized around these points. So if we draw a line down the piston, we can see the line go straight through the axis here, up and straight through the piston head, all in one line. And we can do that quite easily, and we'll use our construction geometry on that. because we don't really want that line showing up, because we won't actually anchor anything to that line. We only anchor to these points. So I'm going to put a line in under construction geometry, and I'm going to highlight both bottom points here. Now I've got 2 points coming up, so I've got vertex 1, vertex 5 and the root. So there's 3 points under that, that's correct. Anchor those in, and I want to constrain this to be horizontal, so we can stick it on the horizontal. Doesn't matter about the length, and we want to constrain this rod here to that center. So click on the point, click on the center line, and use the constraint to fix a point onto an object. So now when we click on here, it still has two degrees of freedom, but we constrained the actual movement to the center, which is what we want. And the last thing we need is the piston head that lays above. So if we look back at our animation, so this piston head here, so you can see where it's connected here. So we can just replicate that in our sketch, come off the construction geometry, and then place our piston head in and connect the points up. Oops, too many. Just those 2 points there. Constrain those, and we just want to keep this a certain length. So I'm going to say 20. Don't want to constrain these two, because that means that we won't be able to move this. So I just want to set this to be constrained along the vertical. So this is constrained along the vertical. I may have said horizontal last time, but it is constrained along the vertical. So now we've got a nice skeleton of the actual piston movement, which we'll use as the base sketch. So I can see by moving this around, clicking and dragging this point, we can see the movement's correct. So this will be our base sketch. We've analysed the actual movement, and we've literally created a graph here of that movement to actually use as a skeleton. So once we've done this, we can move on to the next stage, and that's actually creating the individual bodies that will use this graph. And to start, what we'll do is come over here, come out of the sketch, and go into the part design. And now we can create our body. So I'm just going to create a body in here. So I didn't want to place the sketch inside the body, so I'm going to cancel that, and I'm going to click on unnamed and try that again. So that's not inside the body at all now, so that's good. And with that, I'm just going to create a sketch in there and place it along the XY plane, and OK. So if I move out, I can see my background sketch in here, and what I want to do is import this into our body, because I want to use these constraints to actually constrain our geometry within. Now you can't actually do that, so because if I was going to import an edge, I would use the create edge link to external geometry. I can't actually do that because it's saying it's in another sketch. But that's easy to do, and I'll show you how to do that in a minute. So the first thing I'm going to do is actually get some geometry in here so I can actually constrain it. So I'm going to use this as a base for starters. I'm not going to actually lock anything down. So I'm going to put some rough geometry in here. So I'm going to use the slot geometry, and I'm going to remove the horizontal constraint, and I'm just going to move this in a position that looks about right. Okay, so that's good. Now I'm going to go over here, I'm going to close, and I am going to create another body now. So click on unnamed, click on body, and this one I am going to follow this line here. So I'm going to jump, I'm going to create a sketch going on the XY plane and press OK. So I'm going to put same thing again. I'm going to use a slot to place geometry along here or close to here. So create a slot, and I've got a vertical constraint in there, so I'm going to remove that, and I'm just going to put this roughly in position. And happy with that, so I'm going to close that. And now I'm going to rename parts of these just to make it obvious what they are. So this one is our rod. This one was part of our, I don't know what we call it. I'm going to put cam in there. So we've got our rod, our cam, and then we need our piston head. So I'm going to create a new geometry again, making sure, create a new body, making sure it's separate from all the rest. Create a sketch along the XY plane, okay that, and I'm just going to zoom out. I know it's looking like a pair of paper clips at the moment, but we're going to fix that in a minute. And I'm just going to place in, it's not our piston head, it's the rod that connects up to the piston head. So I'm going to stick another link in here, another slot in here, and I'm actually quite happy with the horizontal constraint in there, the vertical constraint in there. That's absolutely fine, so I'll just leave that there. Hit close. Now I'm going to rename that. And just to rename that to top. Top. Should call it top piston link. Something like that. So not worried about the naming for the time being. As long as we gives us an idea of what they are. So we've done that now. Now, if we try to move any of this geometry about the original sketch, none of it's linked to our geometry that we've actually placed in. So we need to link this geometry to this sketch, but we can't do it because it's part of a separate body. So if I jumped into the cam, for instance, jumped into the sketch here and try to import this, then it's going to say the object belongs to another body and can't link. So what we need to do is that we can actually link to a clone of that sketch, and that sketch will still work. The constraints in the sketch will still allow you to move this object and constrain it to that sketch itself. So you can't constrain to the original sketch because this is the master sketch, but you can constrain to clones of that master sketch, and anything you do in the master sketch will affect those clones. So I'm just going to close that a minute, and I'm going to rename our sketch to master sketch. Now I need to clone this sketch and place it into our cam body here to actually start the constraints on the cam. So to do that, if we jump over to our draft, and what we want to do is click on the master sketch, and we've got to find our clone tool, which if we click on here, there we go, the little sheep here. So it clones the selected object, so we hit clone, and what you'll see in here is that our master sketch has been cloned here, and we can drag this into our cam. Now what we should be able to do now is jump into our cam sketch and actually constrain this to our master sketch. So we should be able to pull it in the sides here, but when you very first do it you won't be able to, because there's a step that's needed. So I'm going to show you that. So if we click on the create an edge linked to external geometry and try to import our geometry, we still get the same problem. The object belongs to another body. Now this is because it's looking at the master sketch itself here. So we've got to make this invisible. So now if we try to do the import, we've actually got our sketch being highlighted. So this is actually pulling from our master sketch now, our cloned master sketch that's inside our cam body. So we just import that. So we now have imported this edge, hit escape, and we can constrain these 2 points together. Oops, need to put a width constraint on this, or a length constraint. That'll do, and I'm just going to leave the height constraint as it is for the time being, and I'm going to constrain those 2 points there. So now you can see that's gone green, so that's a fixed constraint against that length there. So anything we do in the master sketch will actually move that. So I'll show you that now. If I jump into the master sketch and actually just move this slightly and close that, you'll see this has moved. Just show you that again because that wasn't obvious. Let's move it right down here so it's obvious that it's actually moved. Hit close, so you can see that's moved now all through that master sketch. I haven't actually touched anything along this sketch, because if I double click on it you can't actually edit the sketch, but the linked clone has actually passed all those constraints through to our body sketch to allow us to move this. And this is the key to doing any animation, any kinematics. Let's try that one again. Any kinematics for the actual body itself. So we're going to just do the same process for the other bodies. So click on the master sketch, and I'm going to go in our draft workbench over to the clone tool, and we'll create a clone down here. Remember to hide the master sketch here. Change the visibility of that so that's hidden as well, so that doesn't have an effect on when we start trying to import the edges. So I'm going to do this rod here now, so I'm going to just drag and drop. Let's open up the rod first, and I'm going to drag this master sketch into the rod. So we've got that here. Double click on the rod sketch, and I should be able to import this side now and constrain these points up. And I'm going to put a length constraint to keep that correct, and constrain those two there as well. So that's gone green now, so it's fully constrained, can't be moved. And if we jump back to close this and jump back to our master sketch and start moving some of this, so let's move it over here and close, we can see this has moved in relation to that sketch. So the next one I'm going to do is the final piece, which is here, which is our top piston link. So clone the master sketch again. Let's try doing it from over here, making sure you're in the draft. Hit clone. So I've got a third and final clone now, and we want to dump that into our top piston link. And then double click on the top piston link sketch and use the create an edge link to external geometry. And as you can see, I can't actually import geometry at the moment, and that is because if I hit escape, I haven't set this one to visibility, the visibility of this one to hidden. So I should be okay now. There we go. So you can see you must hide these master sketches each time, these clones each time, otherwise you won't be able to import because they lay over the top of the actual one you've cloned. So again, constrain. Oops, let's pull this out a bit. And I've got a horizontal constraint on here, so that's okay. I'm going to constrain the height, sorry, the length of that side, and the width. Okay, so it's gone green now, fully constrained. Close that. So now we've got a fully constrained model, each of them individual body parts, so we can pad, extrude, etc. these bodies, but we can also control it by the master sketch to create the effect that we want. As you can see, it's all moved down now. So we can use Python now in a macro to actually animate this, and that's one of the things that I'll be showing you next after I've padded these parts up, which I'll quickly do now. Jump off into the part design. Oops. So this is saying make independent copy. That's because I haven't actually selected an active body. So I'm trying to pad this one where this body is active. You only can pad the active body, so you just right click on cam on the body itself, toggle active, click sketch and pad. And I'm just going to go for the standard 10mm just to get something in there. There we go, so that's padded up. And do the same with the rod, toggle active body, pad that one, click OK, and do the top piston link as well. Click on the sketch, sorry, make that active, click the sketch and hit pad. So now that's all padded up nicely, and our master sketch will allow us to, ooh, what's happened there? Oh, I haven't. Let's just double check that constraint here. Double click the sketch. So look what's going on. Okay, let's get rid of the constraints on there. So I'm going to just jump down to the constraints and see what's going on. Delete that constraint so I can move away from there. I've got a constraint on the center here. Let's just constrain those back up again and see what happens. I can't see anything wrong with that. All looks good. Pad's correct. Jump into the master sketch. Oh, it's working now. That's a bit strange. Not quite sure what happened there. Master sketch. Yep, it all seems to be working. So something weird happened then, but I don't know what. But that all seems to be working now. Let's just good. Okay, let's jump into part and toggle visibility there. So everything's visible. So now we should see all of this working correctly. There we go. So it's all working. I don't know what actually happened there, but obviously something went awry, and just reconstraining those points allowed me to get this animation working again. Okay, to start our animation, what we need to do is add a few more constraints in here. So I'm going to go over to the master sketch, and I want to add a constraint in here that will be manipulated by the Python macro itself. So I want to put a degree constraint here. So clicking on the two sides, I'm going to hit fix that angle with a line between 2 points, and for the time being I'm going to set this 90 degrees. So that's got a constraint there of 90 degrees, and what that allows us to do, if I close out of here and I'll go into my part design, and if I click on tasks or model, I'm going to get rid of my selection view. I can see now that if I scroll down here, I've got this thing called constraints here after clicking on my master sketch. Now if I drop this down, I can see the constraints that I've got, and I've got this 90 degree that I've just added. Now if I change this and then click on the constraint above, you can't hit enter, you can't change this and enter and see the change, you have to actually click on another field. So I've changed this to something like 60 degrees and then click on another field. You can see this has moved up, and this is what we're going to use in Python to actually manipulate the sketch itself, the master sketch itself, to actually drive everything else on the screen. So let's give this a nice bit of rotation here so we can actually see this working. So there you go, so you can actually see this working. So if you think of this being actually modified, this constraint, via Python in the background, you'll actually see this moving. Now to write our sketch, we need a panel to be visible. So if we go to View, Panels, and then we go to our Python console, this gives us a nice little console down here so we can see what we're doing. I'm just going to center everything on screen, and you can see when I actually click on these toolbar icons up here, you can actually see the Python console changing. Those are actual Python commands going in onto the underlying program itself and actually manipulating the GUI and the actual object itself. And that's what we're going to use to actually allow this to move. So the first thing we're going to do is jump over to macros, click on our macro, and we're going to create a new macro, and I'm going to call it piston rod. Okay, so to write our macro we need to first import a library, and that's to allow us to import the timer, because the timer will be driving all of our animation on the screen. So it's going to write some code in here. So Qt is a cross-platform library. It's actually pronounced cute, this library actually contains something that we want, and that's a Qt timer to drive this all. The next thing we want to do is define a variable that will be used to actually drive the degrees of rotation. So this variable will change. That's the reason why it's called variable, and I'm just going to call this I. So I'm going to set it to 0 degrees for starts. And the next thing we need to do is actually define a method that will be called each time the timer updates. So I'm going to call this method update, and it's going to take no parameters. And because Python is case and white space sensitive, any methods have to be indented. So anything indented underneath the update will be part of this method. So for starts, I'm just going to import I into here. So that allows us to use I in here, and I'm just going to set I, increment it by 0.5. So we're going to increment I by 0.5 degrees, and then leave a space, and that's the end of our method. We're going to pad this out with some extra detail in a moment, but I just want to get the basics down. So the next thing I want to do is actually create our timer. So our timer actually comes from the Qt or Qt core. So timer equals Qt core dot Q timer. Now the timer has a number of events, and the event we want is the timeout event, and I want to connect the update to the timeout event. So timer dot connect dot timeout, and we pass it the function that we want to connect, or our method that we want to connect. Make sure it's spelled right. Actually, that's around the other way, so it's actually timer dot timeout dot connect update. So our timer, our event, and then we connect the update method to it, and then we do timer dot start and how many milliseconds we want to run it for. So each time this timer starts, it will tick every millisecond, and each time it ticks, it hits the tick will cause a timeout, which will run our update function all the time this is running. So now we can test this. It won't actually do anything. We just test it for its validity. So that's fine. So that's actually working. There's no errors that come out, so we can just stop that. Timer dot stop. So that stopped our timer. So that was running, and now we've just stopped it. So now we need to actually affect what's on screen with our update function. So if we jump into our model and we want to go to our master sketch. Now remember, we put this degree in here. If I click on this degree, double click it, watch what happens down here. So I'm going to set this to 50. And you can see we've got a command here that's actually changed the units of that datum to actually 50 degrees, and we can use that in our code. So we'll copy this, jump to the code, and I'm going to place it after I in here. Make sure it's tabbed forward so it's part of the update, and I'm going to remove the 50 from here and actually add I in here, but it's got to be a string, so str I to convert I to a string, and then use the plus to add the degree on the end. So that will drive the degrees, and the next thing we've got to do is actually, if we go back into our sketch, if we hit close, what you'll see is down here it's got this command here to recompute. So that allows everything we've done in that sketch to actually take effect in our part design, or whatever workbench we've got open. So you can see it's activated the part design workbench here, and it's jumped into this app, got that get document unnamed, and recomputed it. So we need that as well. Just take that. And jump over to our macro, and we're going to place it after our command to change the actual datum point. So that should be all okay. So if I save that, Control A, Control C to copy it, go back to our sketch, and if I paste that in, we can see that's all okay. It's actually set to 0 degrees, so we can see our sketch has changed, and we can see that nothing's happening at the moment. Now the reason for that is if we just timer.stop, let's have a look what's going on. Oh, it's because I've got equals plus here instead of plus equals. Let's just try that again. And now you can see it's actually moving. So this is all moving around now. So what I'm going to do is make that a bit quicker. Timer.stop. Change this one to 2. Okay. Copy that, jump back in. And there we go. So we've got the kinematics working in our sketch, and we can actually see this movement taking the place of a simple piston. So I hope that helps. Obviously this is a very simple animation, but you can make this as complex as you like by I'm just affecting one datum point there. I can affect the others, but the main concept of this is to actually use a master sketch to drive the animation through the other bodies, and using Python to manipulate the master sketch and allow for this animation to take effect. Okay, so I hope that helps explain how to use the master sketch, and I'll see you in the next video.